So today, we look closely at the equation. So everyone, let's just read this together. So if you're given a function or a relation, I want you to point to this and say relation. Function is the same as relation. Okay, come on. Every function is a relation. That models exponential. What's that word? Exponential what? Come on, growth. What does that mean? Decreasing or increasing when something grows? Increasing, yes. So everyone, you write increasing here. Increasing. Okay, it can be used to make accurate predictions. What's a prediction? A future expectation. Okay, if you know the initial amount, what does initial mean? What's another word for initial? What's another word for initial? Ending or starting? Starting. Okay, perfect. So initial means starting. Again, understanding the word will let you know a lot about the relation. Starting amount and growth rate. The exponential function is always got to be like this. Okay, so go ahead, highlight. Oh, that's a bad color. Let's go with this. Yes. Okay, can be used to model, can be used as a model to solve problems involving. Okay, what's Pn? Pn is the what? Final. P0 is the what? Yeah, get used to this P0 or something zero. It means at times zero. At times zero. Like when you start your stopwatch right now, if I start my stopwatch, what does it always start at? 0. So whenever you have something with a 0 under it, come on, with a 0 under it, it means initial or starting value. Good. R is the rate of what? Rate of growth. And N is the number of growth. How many times did it actually what? How many times did the population, increase and so on and so forth. Okay. Now let's talk about the opposite. Who can read this word? This one. DECAY. What does it mean? Sorry, who can read it first? Decay. Decay. What does decay mean? Going up or going down? Yeah, well, if we already talked about growth here, that means this one is what? Decreasing. So go ahead. And decay means, it's interesting. Decay, decreasing, they even start the same way. So decreasing. Okay. Again, you know the what? You know the amount. Sorry, the starting amount. The starting amount. And this time you know the decay rate. This is the exponential function. Can someone tell me what's the only difference between those two? There's only one difference, but it's a major difference. One difference only, but it makes it a completely different what function? Come on. What's the difference between this one in green and this one in green? Come on, it's very obvious. Say again. One of them is what? Plus, and one of them is what? Minus. That difference makes it between what? A growth and a what? What's the opposite of growth? Decay. Okay. Guess what? Same thing as well. Pn is the final. P0 is the initial. R is the rate of decay this time. And N is the number of decay periods. So you can really see, come on, focus with me. If you can see, if you understand one, you understand the other. Because they are the same except for one crucial but very simple difference, which is the minus or the plus. By the way, question for you. Listen up. How many people have heard of the word or expression half-life? It's the name of a game, I know, but who also knows what it means? Half-life. So I guess everyone heard it in the context of the game. Okay, does anyone know what it means outside of the context of the video game? Half-life. Okay, anyone here is doing grade 11 chemistry? Grade 11 chemistry. Okay. Who here have heard, listen up, who here has heard of something called uranium or plutonium? Okay, Hamza, what do you know about these things? Elements. So uranium, plutonium, or what? Do you think they're safe elements or dangerous ones? Why are they dangerous? They're not toxic means what? If you like, toxic means biologically, but they're actually physically dangerous. Why? What happens when you have a gram of plutonium or uranium? Do you know what happens? Thank you. Has a what? Radiation. What does radiation mean? Radiation means what? Decay. The element is what? Decaying or what? But why is it decreasing? Because it's giving out what? You just said it's giving out what? Radiation. And is radiation beneficial or harmful? Super, super harmful. Could actually what? Could actually, you like ultraviolet could cause what, for example? Skin cancer and so on. So the word decay is very, very used in what? Half-life calculations. Half-life means what? How long does it take for an element to decay to have how much we have of it now? That's the meaning of half-life. Okay? All right, everyone. So let's go to the first example. Okay. You've got a bunch of functions. For each function, listen up. For each function, you have to tell me three things. First, you have to tell me, is it growing or decaying? And you have to say why. Then you have to tell me what's the initial value. And then you have to tell me this. Is there another thing or that's it? That's it. Okay. Come on, focus. Haley. Okay. Is this one growth or decay? Without sketching or using Desmos. How can you tell? Haley, go ahead. So hold on. Growth or decay? Why is it growth? The number in brackets is bigger than? What do you call the number in brackets? Come on. What do you call the number under the exponent? Base. The base is what? Bigger than 1. Perfect. So everyone, we're going to say growth or decay? Growth. Growth. Because base equals how much? 1.02, which is bigger than? Bigger than what? Bigger than 1. Okay. That's the first part of the question. Second part. Oh, actually, let's do a quick graph, everyone. So how do you do a quick graph? Nothing. You sketch how many axes? Always 1 or 2? 2. You can never do anything with one axis. Okay. Here's my question to you. What are the names of these axes? Are they y and x or what? So which one is v? Is it the vertical one or the horizontal one? Which one is the v? This or that? This or that? Which one is v? I'll give you a hint. Related to y and x. Kaylin? Yes, everyone. This one in bracket is always where? Here. Which means this one is here. Good. So let's put v here. Capital V, by the way. Make sure it looks capital. And this one is small t. Okay. Can someone tell me what's the initial value here? Come on, just look at the function. Which number is always the initial value? 20. The number before the bracket is the what? Is the initial value. And did you say that this one is growth or decay? Growth. So does it make sense to put the 20 here? Because I don't have what? Space. So that means I have to go somewhere below. Okay. What's my base, everyone? What's my base, Shadi? 1.02. Is it a lot bigger than 2 or slightly? So is it going to grow very fast or slowly? There you go. So take your time doing the what? Doing the curve. Sorry, that looked linear. My bad. Yeah, I think so. Are we told that this model or this function ever stops at a certain year? So what should I put at the end of this curve? Thank you. Perfect. We're not told anything about how good it is until when? Nice. Oh, and we put what here? Please always let me know that this is at 20. Okay? Oh, my bad. So what's the initial value? 20. So initial value equals 20. Why? Honestly, not much of a reason. You can say, because it's the one at the beginning. What's up? What do you want to say? Yeah. So everyone, here's what I want you to do. Write the function. Just write the function the same way. 20, what is it? 1.02 to the power of t. And then just circle or highlight or underline the 20. Okay, that's it. Honestly, that's the only reason. It appears at the beginning of the function. Done. Okay, last question, which is usually the hardest one to do. It's not really that difficult, but it's just the new idea. What is the growth / decay rate? We already said this one is what? Growth or decay? Growth. Okay. What is the rate? Okay. Let me show you something, everyone. Everyone, pencils down. I'll show you how easy of a calculation it is. Okay. Everyone, which equation are we going to use? The top or the bottom one? Why? Because this section is for the what? Is for the growth, and this section is for the what? For the decay. So let's look at this function. What's your base here? 1 plus. And what's our base in the question? No. What's our base in the question? No. In the question. In the question itself. What's the number for the base? 1.02. So what does that tell you? 1 plus r is equal to what? 1.02. You got it. Is that an easy equation to solve? Super easy. Look. Let's do this. 1 plus r must equal what? 1.02. Who can tell me how to solve this equation? You only need to do one step. Literally, just one step. Yeah, go ahead. Hamad, go ahead. What do I do? Yes. I take the 1, and what do I do with it? Move it to the other side, becoming -1. Thank you. So the r is 1.02. Let's actually write it at the beginning here. Sorry, give ourselves some space. R equals 1.02 minus 1 equals, how much, Shadi? 0.02. Okay, everyone, listen up. If you leave it like that, I cannot say that's wrong. That's actually correct. However, listen up. Because of the end of this unit and all of next unit, we always want to express the rate as a percentage. Does anyone remember from grade 9 or 10 or whatever how to go from a decimal to a percentage? Which, by the way, is always the opposite of how to go from a percentage to a decimal. Louisa? Say again? You take the decimal and you multiply by what? By 100. How about if you want to go from a percentage to a decimal? You take the percentage and you divide by 100. Nice. So what do? Nothing. I just take 0.02. Here it is. 0.02 times it by what? How much? Yeah, don't just say 2. You have to say what? 2%. Thank you. So you just say R equals 2%. What does this mean? Every growth period, this function grows by how much? By how much? Okay, I'll give you an example. What does this mean? Omar, I'm going to give you $100 right now. How much do you have? $100. Tomorrow, I'm going to give you what? 2% extra. How much is 2% of $100? $2. So tomorrow, I'm going to give you what? $2. How much do you have right now? By the way, you didn't spend any of the original 100. So how much do you have on you right now? 102. Guess what I'm going to give him tomorrow? I'm not going to give him $2. I'm going to give him 2% of, no. No. I'm going to give him 2% of the new amount, which means what? I'm going to give him slightly over what? $2. I'm going to give him $2 and a few cents. Look. Yes. Every day, it's 2% of what you just had when? Not at the beginning, but just what? Yesterday. So how much is 2% out of $102? 0.02 times what? How much should I give Amr next day? $2.04. So how much does he have now? $2.04 plus what? How about the day after? 2% of the what? Do you see what I mean? Every day he's getting what? Slightly the same thing or slightly more? Slightly more. Good. Nice. Okay. Everyone, how about this one? Growth or decay? And you have to tell me why. You can just guess. How many people say this is decay? Okay. Sadia, what magic number tells you it's decay? The base is how much? 0.8, which is between 0 and 1. Perfect. So everyone, we're going to write this first. Decay because base equals 0.8, which is less than 1. Okay? Help me out with sketching it. Let's sketch it real quick. This. Can someone tell me what are the names for the axes? Again, not always y and x. Look at the problem. What are the names for the old y and then the old x? P in here and n is here. Good. So everyone, P here and n here. Did you say growth or decay? So am I going up or going down? So I think it would be a good idea to start from here and just make your way down. Are you ever going to touch? What did we say about exponential relations? Does it ever touch? But does it get closer and closer and closer? So just, you know what? Just, you don't even have to really get close to the what? To the axis. Just go like this, and I'll give you full marks. But I need one thing. Who can tell me what's the initial value here? Hold on. Don't say it. If you really know, raise your hand. Okay. Shadi? Why 1? Where's the 1? It's invisible. If you want to make it visible, where is it? Before the bracket. Everyone, go ahead and put a 1 here. What if someone says, everyone, listen up. What if someone says, it's not a 1, it's a what? Because it doesn't appear. Why do you disagree with that? That's wrong, by the way. Why is it wrong? Why is it wrong to say that because it's not there, it's a 0? Haley, you take it this time. Anything times 0 is what? Do you even get a curve? No, you get the what? You get a 0 line here, which is incorrect. Nice. Okay. No. What if someone says this is 0? Yeah, which means no, it will stay 0 forever. 0 is a constant 0. It doesn't change. So it will always be what? Dead forever. Nice. Okay. So technically here, what do we say? Initial value is 0. Sorry, I mean 1. Thank you. Initial value equals 1. Why? I'm just going to write the function, but I'm going to highlight the visible one now. 1.8n. And we highlight the... Oh, my body. Sorry. Yes, you're right. It's a T and an N. Thank you. T and N. Nice. Can someone tell me now how this one is going to change? One small change, but will make a huge impact. One small change. Muhammad, go ahead. Plus or minus? Minus. Everyone, this becomes what? 1 minus r equals how much? And then we'll solve. Okay. So 1 minus, sorry, that's a 1. 1 minus r equals 0.8. Okay. How am I going to solve this? It's not move what? Do you need to move 1 or 2 things? Okay, Shadi, what is the one thing? I'm not saying you're incorrect, but what is the one thing that you're going to move if you want to move just one thing? But I agree. It will be, it's already a plus. So if it's going to move, it's going to become a what? A negative. But would this one change? No. Okay, Haley, go ahead. Exactly. I'm not, oh, by the way, technically, can you have a negative variable? Yeah, but should you? So how many movements should I do? 2. Everyone, I should move at the same moment. I should move this one where? And this one. But someone might say, hold on, your variable now is on which side? The left or the right? When you move it. Which side? The right side. Is that so bad? Is it so bad to say, everyone, is it so bad to say 2 equals x? But when we write the final answer, how are we going to write it? X equals. So it's okay to have this now, but make sure that you what? Flip it nicely at the end. Nice. Okay. So as we said, we're going to move this one. I'm going to actually circle it. You don't have to circle it, obviously, when you do the test. Yeah, at the same time. So I'm good. No? Yeah. I hope it's not super, confusing. Then what? 1 minus 0.8 equals what? R. Which means R is equal to what? 0 point? Is it 0.2 or 0.02? 0.2. How can we switch 0.2 to a percentage? We multiply by what? 100. What's 0.2 times 100? It's not 2% this time. It's how much? 20%. Thank you. Very good. Okay, the last two, listen up, are homework, but I will start you off with each one. So everyone, let's look at the next one. Everyone, is this growth or decay? I don't think so. It's a 0.5. It should be decay. It's not this number. It's the number under the what? Thank you. It's under in the bracket or under the what? Under the x or under the variable. Nice. So this one definitely is what? Growth. So let's just write growth quickly now. Okay, what's your initial value? Initial value. There's only one other number. 0.5. Okay, is this, we said this is growth. So is it going to be plus or minus? Growth is always positive. Growth is always plus. So you say what? 1 plus r equals how much? What was the base? 3. How can we solve this? Come on. You move the 1. You see, when it's a plus, it's an easy thing. You just move the 1. So r equals what? 3 minus 1, which means r is equal to what? Okay, this, everyone, this is starting to not make sense. Is this a decimal? Hold on. But to make it a percentage, do we still do the same thing? What do? We multiply it by how do you go from decimal to percentage? You multiply by the magic number of 100. What's 2 times 100? 200 what? What does this mean? By the way, usually, does anything grow by 200%? Usually, it grows by less than what? 100%. What does it mean, 200%? It means, I'm going to give you today I'm going to give you $2. Tomorrow, I'm going to give you 200% of what? $2. What's 200% of anything? Double it. So tomorrow, I'm going to give you what? $4. How much do you have now on you? Add it. 4 plus 2 is what? 6. How much am I going to give you tomorrow? Double the 6. So how much am I going to give you? 12. What's 12 plus 6? 18. How much am I going to give you tomorrow? Double of what? No. 18. Do you see what I mean? Add it and then claim that you want double of that. Do you see what I mean? That's why if you have exponential, it grows very what? It grows very what? It goes very high, very fast. You see what's happening? The first day he had $2, right? I gave him 4. So the second day he had what? 6. I gave him 12. So the third day he had 18. And then I gave him 36 because that's double of 18. I am giving him double of what he has every single morning. He is growing his money very, very highly. Obviously, that doesn't happen in real life, but in general, that's what this means. Okay? Okay. You going downstairs? Yeah. Who can tell me what this one is? Is this, everyone, is this growth or decay? How many people say this is growth? Why would you say this is growth? Like, what number are you looking at to say it's growth? Come on. The 5. What's my whole base? No, but what is it? 5. Oh, it's a fraction. And what does this fraction happen to be? If you divide 5 by 8, what do you get? Do you get something bigger than 1 or less than 1? Do you even need to do this to prove it? No. $5 divided by 8 people. Is there any way that each person is going to get more than $1? No way. What if my base was 8 divided by 5? What would the situation then be? It would be bigger than 1, which means it will be what? Will be what? Going up. Nice. So everyone, remember, I could give you the base as a fraction. You still have to decide if it's less than 1 or bigger than 1. So you know what? Let's actually write what that is as a decimal. How can we find this as a decimal? Nothing. How did you do that? You just what? You just physically divide and you see whatever the calculator gives you. 5 divided by 8. No doubt, that's a less than 1 decimal. Done. So everyone, you can highlight this if you want. Everyone, just highlight this part. Just this part, and maybe point to it and say what? 0.6, sorry, 0.625. Nice. So that's a decay. What's your initial value? How much? Yeah, whatever this models, it starts with 600 things at the beginning. Okay. How should we do the calculation here? Can I do it with the fraction? What do you think? Do you think I can do it with the fraction? Can I? Can I do it with the decimal? Again, by the way, did this end up being a long decimal or a short finite one? Yeah, so you know what? If it's a short, good decimal, perfect, you can do it with a what? With a decimal. I wouldn't do that. You see what I mean? Again, depending on how long the number is, you might have to round. Do you really need to think you round this one? Not really. Again, you don't want to round, you should use the what? You should use the fraction. Okay? But you know what? To your point, let's do the decimal. It seems to be much easier. All right. Is it 1 minus or 1 plus, though? Is it growth or decay? This is decay. What do you do when you have decay? Not plus, you do what? Minus. So 1 minus r equals what? 0.625. How many things do you move? 2 things. You move this guy here, and you move this number here, becoming a minus. So that means what? That means 1 subtract 0.625. You know what? Again, you don't have to show me the circle and the movement, but I'll do it because I'm teaching. Equals r. What's 1 minus? Oh, I forgot the 5. My bad. So r is equal to what? What's 1 minus 0.625? 375. Yes. What is this in percentage? Anyone? Who knows the quick trick to moving decimal points with percentage? Patrick? How much is the answer? How many? Exactly, everyone. When you multiply by 100, look, you hop the decimal point twice. Once, twice. So what's the answer? 37.5. You have got to say percent. You just can't put the number by itself. It's a percentage. So 37.5. Let me just squeeze it. Squeeze. Percent. I have to say, if you don't put percent, I have to take half a mark off. Because 37.5 is not the same as 37.5%. One of them is a number, one of them is a ratio, is a percentage, is how much you have of something. Yes, Hamza. Go ahead. Listen up, everyone. Go. Okay, question to you, Hamza. R here, is it positive? So that's good news. R here, is it already on the left side? Is that even further good news? So do I need to even move the R at all if it's positive and on the left side? I don't. How about here? It's what? It is on the left side, but it happens to be what? Negative. So what should I do? Yep. Again, I might be losing it on the left side, but at least I'm gaining it what? Positively on the right side. That's absolutely fine. Yep. Go ahead. Okay, everyone? All right. So, everyone, let's go to the second page. Do an actual what? Full word problem. Full word problem. And by the way, my test word problems are very similar to these. So make sure your solutions are detailed because you sometimes might end up just copying the steps. Okay. Again, with the population. A town this year, 2021. I guess I did not change the date from last year when I taught this. You know what? Fine. Let's say 2021. Has a population of how many people? Very, very small town. Its growth rate has been how much? What does that mean? Every year, the population grows by how much? 2.5% of what is it? At the beginning of the year. The function that models or describes, this should be describes, my bad, the town's growth is, by the way, how come the number is like that? Again, what is the rate? 2.5%. Everyone, what's 2.5% as a decimal? See, now we're doing the opposite. I want you to go from percentage to decimal. What do? Do you multiply by 100 or divide by 100? Divide. So let's divide 2.5 by 100. 2.5 divided by 100. How much? Because it's growth, am I going to subtract this from 1 or add it to 1? You see the relation? You can always build it once you know if the town is growing or decaying. Okay, no problem there. The above population, P represents the population. Oh, hold on. Represents the population in what? How many people actually live in the town? How many? What's the number we used in the function? What does that mean? Are we scaling the problem up or scaling it down? For the math, we're scaling it what? So make sure that your number here, when you want to use it in real life, you multiply by how much? 1,000 to bring it back to the number of people. Okay, so again, by the way, do they use this a lot? They do. Let's say, for example, you're everyone. Let's say you're reporting. I don't know the oh my god the the money, for example, of a certain country. Would you expect that to be a small amount of money or a huge amount of money for a country? Usually huge. So would it be in actual dollars or should you talk in millions? You should talk in millions or even sometimes what? What's after a million? No, before that. A million, after it is a what? Billion. After a billion is a what? Trillion, okay? So obviously, you can just say what? Oh, this country has 2. It doesn't mean it has $2. It could have 2 what? 2 million or 2 billion or 2, depending on what scale you want to say. Okay, so remember, the math sometimes scales the number down because you don't want to keep writing 12,000 every time. Okay, everyone, let's sketch a diagram. What's my vertical axis? Which one is my vertical axis? Right there. No, no, no. What's the letter here? P. Thank you. It's pop. It's whatever is here. So that's a P. What's this one? N. Do you remember what N was in the problem we did on Friday? Was it the year itself or what? The number of years since we started. Apparently, what year did we start? 2021. So everyone, I want you to write. So N equals number of years, YRS, after which magic year? Yeah, after 2021. Okay. Do you remember what happened when we plugged in 2015 as an exponent? What number did we get for the population after, what was it? After like, yeah, but what kind of number did we get? An insane, it was in the billions of millions of people, which would not even be the population of the earth for like thousands of years. Okay. All right. Is this growing or decaying? So should I be going down or going up? So that means we need to choose a spot. Maybe I don't know. Maybe here. Sure. Everyone, let's put the initial value here. What should you put as initial value? Should we put 12 or 12,000? How many people say 12? How many people say 12,000? I mean, Do they still mean the same thing? They do. 12 in the math mean 12,000 in the what? In real life, right? But technically, is this a graph of the real life or of the equation? Technically, it's of the what? It's of the equation. Should we put 12,000 or 12? We should put whatever we see in the actual equation itself. Is it making sense? But we understand it's not 12 people, it's how many? 12,000 actual people. Good. So everyone put 12. Actually, put it in quotation marks. Just so you know, it means something else. And then just go up. Are we told this model stops at some certain year? It doesn't? Nope. So what are we assuming? For our purposes, it goes what? Forever. Yes, it never stops. Nice. By the way, as I told you on Friday, that never happens. Every model must end at some year. Why? Because resources and money and food and space, they always what? Impact the model. Yes. Let me just finish with just the second one. Okay, done. Now let's look at the second problem. Determine the population of the town after 10 years. After the year what? So do you need to figure out any numbers, or do you already have the number to plug in? I already. What could be another way of asking you the question where you still have to find how many years passed by? I will give you the what? I will give you the year, which will be which year, by the way? 2021 plus 10. How much is that? 2031. If I told you that, you have to subtract from 2021. Nice. So everyone, we just say what? Use n equals 10. Okay, let's plug in the number. P. Okay. Everyone, what did we say use the n as what? So what should go here? No. I'm telling you, the n is 10 years. So what do you just put instead of the 10, instead of the n? 10. Everyone, I'll accept two ways. Some teachers wants to see this. How many people have seen this notation before? Yeah, you're telling yourself n equals what? Is it okay if you just put 10? If it is, because you just told me n is 10, I will accept either notation. I will accept either this one or what? Or just what? I'll put them like this for you today to decide whichever one you like. All right. Equals what's my 12? 1.025 to the power of n or 10. Once you know a number, once you know a variable number, go ahead, put it in. All right. Hamza, which part of this should I do first? Always. Yeah. What do you mean by left side? Like which part of the equation should I evaluate first? The multiplication or the exponent? The exponent, because of what? Bed mass. E is before m. Exponents is before multiplication. So that means first, I have got to evaluate this thing. Okay, so it's got to be 12 times something. 12 times something. I don't know how much 1.025 times to the power of 10 is. 1.025 to the power of 10. Oh, question of everyone. Do you remember how many digits we used to do in trigonometry? You know what? Let's follow the same thing here. Okay. So what would this be to four decimal digits after the decimal? 1.280. Okay. If I want to stop here, it stays as what? 8. But if I want to stop here, what does this 0 become? Good. So we're going to say times 1.280. What's up? Oh, because remember, if I want to stop here, this 8 bumps this guy to a 1. Right? If I want to stop there, and I want you to stop at 4 digits. Okay. So times what? 1.2801. Okay. How much is that? 12 times 1.2801. 15 point what? 15.361212. Okay. Okay. Hold on. Is this the number of people in the town? First of all, can you, if you're growing, Haley, if you're growing, can you go from 12,000 people to 15 people? First of all, that doesn't make sense. What also doesn't make sense about that number? Yes? Exactly. Can you get a decimal number of people? No. So what do? Is this a math value or an actual real life value? That's the math value. How do you make it real life? You multiply it by a what? By 1,000. Okay. So you just have to. Oh, that's the news, like daylight saving time thing. What would this be if you multiply by 1,000? What happens to the decimal point? How many times? 3. As many zeros as you multiply by. So what do you get? 15, comma, 361.2. Do you remember how we expressed our answer at the end of the question on Friday? We said you have this many people. Haley, we said 2 words after. Hmm. No. Go back to your notes. What did we say? What did we say at the end of estimating the number of, so to say? At least. Which means what? Do you have to round? No, you don't. You just cut the number. So how many people at least do you have in the year 2031? 15,361. Does it matter that the 0.2 doesn't round the 1? No. You cut it because that's how many people at least live in the town then. So that means, by the way, don't say equal. Do not say equal. Say an arrow or leads to 15, comma 361 at least. No, the last two. No, no, the last two is not homework. The last two are a new idea. So actually, I'll do just one of them. Okay. Can someone read part B for me? Come on. Yeah, Hamza, go ahead. Interesting. Everyone, am I giving you the year and asking you for the people, or am I giving you the people and asking you when is that going to happen? I am asking you determine the what or the actual year when the population what? What does double mean? Whenever something double, you just multiply it by what? What was the original number of people in the town? You, go ahead. What was the number? When 12,000 doubles, how many people live in the town now? How many? So the question is saying what? Which year should we expect the number of people to hit what? To hit how many? 24,000. Or the number of years until we use what value in the equation? 24 only. Remember, you use 1,000 times less in the math than in the what? Than the equation. So let's just write this down. So I want you to write this. New population population equals 12,000 times what? How much is 12,000 times 2 again? 24 grand or 24,000. Okay. Let me just squeeze. Okay. So instead of using n, what do I use now? I don't know the n. I want to find the n. What do I know? Which variable? Capital P. So that means what? Use, everyone, use P equals. Is this correct? Not quite. Remember, we do not use the actual number of people. We use what? We use it scaled down by 1,000, which means what do I scale? Just what? 20. That's it. So we use P equals 24. Okay, everyone, pencils down once you get to that, because I just want you to focus on what's going to happen next. Is anyone still copying this? Okay, no problem. We have enough time. Okay, everyone, eyes on me, phones away. Just look at this. Here's the equation. Question for you. If you do not write this n, are you still okay? What do you think? If you do not write this n, like if you completely skip this bracket and you just write what? Capital P, are you still okay? How many people, show of hands, how many people stay? You're still okay. Sophia? How about if you do not write this n? Are you okay? Because the whole thing would what? Would not be exponential. So that means what? Everyone, which n can we skip writing? The first or the second one? Okay. So imagine, everyone, imagine if we don't have this. Which value do we know now in the part of the question we're trying to solve? Do I know the n or do I know the p? When you know a variable, what do you do? Do you keep it a variable or do you put the value of it? All right, good. So that was my whole point. So many people are stuck on always writing the what? You do not have to write it if you're solving backward. If you're solving backward, don't write it. So we're going to say this. Look. P, oh, my bad. P equals what? 12, 1.025 to the n. Which one of those do I know now? The what? The 24. So 24 is going to go in here. So here's my new line. Everyone, my new line is 24 equals 12. Nice. I went from two things to one, like two variables or two unknowns to one. Who can tell me what do I need to do first here? I need to clean this up. Okay, hold on. Did you just say multiply the 12? By the way, I can't do anything with that because I still don't know the what. I still don't know the n. So I can't really fully know the right side. But I need to clean it up. Shadi, what do you think we should do? Okay, I'll give you a hint. Which number is more annoying here? This guy or this guy? Which number is annoying? Is it the 1.025 or the 12? How many people say the 12? The 12 is the annoying one. You know why? Because if it was gone, I would solve this in like less than a minute. So how do we cancel the 12? Do we multiply by 12 or do we divide by? Yeah, or divide the 24 by it. Yes. So everyone, let's divide by both sides by 12. So that means divide by 12 and divide here by 12. Okay. What's 24 divided by 12? 24 divided by 12. 2, not 1, 2. Okay, what's 12 divided by itself? What really just happens? 1 or cancels out. So what do you just have? 1.025 to the what? How do I solve anything? Everyone, how do I solve anything that looks like this? We have to play what I like to call the guessing game. What does the guessing game mean? Keep guessing values of what? Of n until you get very close to what? To 2. All right. Rawda, give me a value for n. Could be, just don't go super big. Give me a value for n. And make it a whole number. Don't go to decimals. 10. All right. 10. So Rawda's saying what? 10 years. All right. So everyone, that's clear. 1.025 to the power of 10. What did I get? 1.28. I need to get how much? I need to get how much? Okay, so 10 was good, but I need still to go what? Lower or higher? I need to go higher. Okay, Rami, give me a value. 60 or 16? 60. All right, everyone, clear again. 1.025 to the power of 60. Okay, so we did go up, but did I undershoot or overshoot? I overshot a lot. But at least now we know that 60 is too what? Too high. So we know it's between 10 and 60. Sure. Hold on. Let's try 30 and no. That's the whole idea. We're gonna try big numbers and then we're gonna what? Fine tune it. All right. You said 30. 1.025 to the power of 30. Do I need to go higher or lower? But a lot or just a little bit? Good. So maybe 29. All right. By the way, just so you know, everyone, what if you get, should you get a number that makes you undershoot or overshoot? Always, no, always slightly what? Because then you can tell me I need to at least go this number of years to see this number of people. So we're going to say 29. All right. 28. Yeah. Okay. Okay. No, I think no, no. 26 probably will take you more, less than what? Less than 2. So let's try 28. 1.025 to the power of what? 28. Is it very, hold on, is it very close to 2? But is it more or less? We always know to go slightly more. So 28 was less. So what's a better candidate? Okay, so here's my question. Is 29 a good answer? Can I make it 28.5? What? How are you going to choose your answer? It depends on the question. If the question says what? 1 decimal, we should use what maybe? 28.5. Do you see what I mean? The guessing is going to depend on how good your answer should be. Does it say anything about, everyone, guys, does it say anything about rounding? So should we use a decimal or a whole number? I think we should use a whole number. All right. So what whole number are we going to use? 28 or 29? Because 28 gave us what? Over or undershoot? Never undershoot. Always what? Overshoot. So at least then you can say what? This number of years at least has to pass by for me to see 24,000 people in the town. So that means I want you to write this. Guessing. I actually want you to write guessing so you know how we got to it. Guessing. We get n equals 29. 29 what? Months or days or years? We have the unit of time to be years. Okay, I know the question did not ask which year, it asked what number of years. So does that mean we're done? Actually, it does, because if the question asks determine the what? Number of years. And this is the actual what? Number of years. What if the question said in what year? What do you do? Which year did we start with? What was the year of starting? 2021. How many years has it been after 2021? So what do you do? Do you subtract or add? Are you going backward into the past or more forward into the future? You can never go backward. You have to what? Add. So that means what? In the year equals 2021 plus 29. Hey, which year is that? 2040 or 2040. In 2040, we expect the what? We expect the population to hit how many people at least? So 24. Oh, my bad. Sorry, which year? 2050. In 2050, we expect the population to hit how many people? 24,000. Not just what? Not just 24. It's going up all the time. So equals 2050. You don't have to do that. The question didn't ask for it, but that's okay. Okay? Can you tell me how we're going to do this one? Is that very similar to the one we just did? Yes, but are you already given a what? A population. What's the population we're trying to hit now? So am I going to use 80,000 in the equation or just 80? Okay, everyone, just write this. Use P equals what? 80, not 80,000, 80. Which means, how many people say you're going to repeat the exact same thing? Raise your hand. Ahmed, hello. How many people say we're going to repeat the same thing? Yeah, but instead of 24, I'm going to use what? And what are we going to do then? Divide by what? No, always divide by what? This number. This is the annoying number. And then you're going to play which game? The guessing game. Are you going to undershoot or overshoot? You always have to what? Overshoot means what? Go slightly higher. How high? Just a little bit. Okay? That's all. Done.